Hi friends, welcome to Sri Chaitanya. This is Umasankar, Holiday 8 coordinator. So far, actually we are now concentrating on vector algebra, and after that now we are concentrating on properties of vectors. So far successfully we have completed 5 lessons of the properties of vectors. This is lesson number 6. In first 5 lessons, we have practiced and concentrated the basic definition and applications of the properties of vectors. Based on the basic definitions of the vectors and addition and subtraction of the vectors and establishment of unit vectors, direction cosines, angle between the vectors and collinearity, coplanarity. Now this is about properties of vectors, lesson number 6, and with this lesson we are solving some of the application oriented problems based on applications of the properties of vectors. In physics especially, and especially in JEE Mains examination, they are asking these models very frequently, and the same questions we may also create or construct in complex numbers also. That is why there is an interlink between complex numbers and vector algebra. If anybody is mastered the vector algebra, complex numbers becomes very easy. Visualization in solving the problems of complex numbers becomes very simple for them. So now today through this lesson we are just concentrating on the application and properties of the vectors. Now see my friends, read the statement properly. What is given? If the resultant of two forces is equal in magnitude to one of the components and perpendicular to it in a direction, find the components. See my friends, actually before solving this problem I need to explain, I need to give some data for you. What is that data? See, this is my OXYZ plane, 3-dimensional plane. Because in vector algebra we are mainly concentrating on a 3-dimensional frame of reference OXYZ. This is x axis, this is y axis, and this is z axis, and this is called xy plane, this is yz plane, and this is zx plane. And of course along x axis in general the unit vector is I, and reverse to it there is minus I. Along y axis the unit vector is j, and along z axis the unit vector is k. These are all the standard inputs. And of course if P is any point in this space or in the plane of OXYZ, let it be A1 comma A2 comma A3, then OP bar becomes what? Position vector of the point P with respect to O as origin. Then OP bar is nothing but A1I plus A2j plus A3k. Here A1I, this is called component vector of OP bar along x axis, and A2j, this is called component of vector OP bar along y axis, and A3k, this is a component of the vector OP bar along z axis. So you need to understand the definitions between terms like a component. Okay? So in that aspect only I just introduced this terminology for you. Now coming to the question here, if the resultant of two forces is equal in magnitude to one of the component and perpendicular to it, what is given? Suppose two forces are given for you. Let us say P and Q be two forces and R be their resultant force. So what is the duty of R, or what is the behavior of R? The resultant of two forces is equal in magnitude. So R is equal to P, and moreover R is perpendicular to it. R is perpendicular to P. This is given for you. So what are P and Q? P and Q are two forces given for you. Say for example, this is some force P and say for example, this is say some force q, and this is angle between these two vectors, and this is the resultant, and this resultant is r say, and this r is perpendicular to one of the force, and moreover magnitude of r is equal to magnitude of p. These are the this is the information given for us. Then what we need to find? We need to find its components. Actually, the same problem we can solve in simple way if you are having knowledge on dot products and cross products concepts. But without that, without helping of those particular areas, just with elementary knowledge only, how to solve is the most important point. Here I am now concentrating, I am now solving this problem in that way. See, my friends, without loss of generality, I have taken this is my one force and this is another force, and this is the resultant force, and these are the terms and conditions given from the hypothesis. Okay, this is A, B. So without loss of generality, what I take in, I have considered this is my origin, and my first force is along x axis and my resultant force is on y axis. Conveniently I have taken. There is no harm if I assume like this. So what is given for me? Let the two forces be P and Q, and R is the resultant force. Let OX and OY, the line of action of forces P and R taken respectively, and X and Y respectively, and let the angle between P and Q is theta. Suppose the angle between P and Q is theta. This is the information given for me. Now, what is given? So unit vector along OA bar. So unit vector along OA bar. If you know, since this is angle theta, and this is my magnitude, and if it is an angle theta and if it is magnitude is q, therefore this is the unit vector along OA bar. Actually, if along x axis you know I cap is the unit vector, along y axis you know j cap is the unit vector. Suppose if any vector, suppose this is the situation, this is angle between two vectors, this is A bar, and suppose this is B bar, and the angle between these two are, this is theta, and one vector is along like this, then the component unit vector along B bar is nothing but cos theta I plus sin theta j. This is called unit vector along, because I know theta. How to get it, I will explain, don't worry. So unit vector along OA bar is cos theta I plus sin theta j, and now force along OY bar is, since R is equal to P, because that is given, therefore Rj is equal to Pj, because magnitudes are same, and unit vector along y axis, along y axis is j, therefore Rj is equal to Pj. Therefore force along OA bar, this is unit vector, therefore force, now force means this quantity q into unit vector, that is q into cos theta I plus sin theta j. This is what unit vector force, component of, that means force along OA bar. Actually the component of OA bar I can say, but force along OA bar I am writing. Now R is what? A resultant of P and Q. Therefore R is nothing but Pj, because Pj is nothing but Rj, is equal to resultant means this vector plus this vector. So Pi plus Q into cos theta I plus sin theta j. Simplify this and compare the corresponding coefficients. So here I coefficient is 0, and j coefficient is what? See, here I coefficient is 0, therefore P plus Q cos theta is equal to 0 and Q sin theta is equal to P. Therefore by solving these two we will get theta as, tan theta as what? -1, therefore theta is equal to 135 degrees. Therefore after simplification you will get Q is equal to root 2P. So this is about what as per the statement what they are asking. They are asking you to find what? The components. This is the way to find the components. Okay, my friends. So here the important point one should practice is that, all unit vectors in xy plane is this one. Unit vector along x axis is I only, unit vector along y axis is j only, but all unit vectors on xy plane, this is the concept, cos theta I plus sin theta j, because it is very simple. Say this is my origin and this is my x axis and this is my y axis, this is I unit vector along x axis, this is j. Suppose on xy plane, this is the point say px comma y, because I have considered on xy plane only two coordinates will come. Join a perpendicular p on x axis, this is nothing but y, and join a perpendicular p on y axis, this is nothing but x, and join OP. And if it is theta, then from the diagram, and say the distance between OP is equal to r, let it be. Therefore, cos theta is equal to what? Cos theta is nothing but this length. This length is, say this is q, OQ by OP, that is OQ means x by OP means r. Therefore, x is equal to r cos theta. Similarly, y equal to r sin theta, isn't it? My friends, now if p x comma y as a coordinate, I can also write it as r cos theta comma r sin theta. If these are the coordinates, how can you write position vector OP bar? OP bar is equal to r cos theta I plus r sin theta j. This is what? Position vector OP bar. But if this is any vector, but unit vector means magnitude is 1, that means mod r is equal to 1. So, unit vector along OP bar is now it is nothing but cos theta I plus sin theta j. That is why all unit vectors in xy plane is cos theta I plus sin theta j. You please remember this concept. If you have understood this one, then solving the problem becomes very easy for you. Okay? Just with the simple trigonometric substitutions and calculations, you can do the problem very easily. Now coming to the second question. Yeah, read the problem very carefully. The wind is blowing due south with a speed of 3 meters per second. How fast should a car travel due east in order that the wind shall have a speed of 5 meters per second relative to the car? My friend, here the terminology is again speed, that is important. Speed is what? A scalar quantity. Velocity means vector quantity. Distance, scalar quantity. Displacement is vector quantity. So, here speed is given, okay, and speed what? This is toward wind shall have a speed of which has wind shall have a speed. So, speed of the wind is what? 5 meters per second is with respect to what? Relative to the car. Again, the most important terminology is relative to the car is given. That means, see, this is the situation. Without a loss of generality, you imagine x and y axis, and this is about north, and this is the south, and this is east, and this is west. So, what is given? A wind is blowing due south. So, wind is coming like this. Wind is blowing due south, okay, with a speed of 3 meters per second. So, of course, unit vector along x axis is I, unit vector along y axis is j, okay. Then unit vector along OS bar, that is minus j, and speed is given as what? Speed, wind speed is what? The wind speed is given 3 meters per second, therefore, velocity of the wind minus 3j. It becomes what? Minus 3j. So, velocity of the wind is what? Minus 3j. Because I know the speed of the wind, but velocity of the speed, because it is moving downwards, means in south direction. So, velocity of the wind is, and again suppose velocity, speed of the car is x meter per second, because I have considered my magnitude, that means speed of the car is. So, velocity of the car is what? Xi. This is xi, because it is moving like this. But what they are asking, what they are asking, how fast should a car travel due east in order that the wind shall have a speed of. So, we need to find how fast how fast that car should travel due east in order to have the wind have a speed of 5 meter per second relative to the car. That means to get the speed of wind relative to the car as 5 meter per second, how fast the velocity of the car would be, that they are asking. So, here what I am doing is, let the speed of the car be like this, therefore, velocity of the car is like this, therefore, now velocity of the wind relative to the car is this one. So, this is what this is velocity of the car is xi. Now, velocity of the wind relative to the car is what? Like this. This is resultant. So, minus xi, resultant is minus xi minus 3j. This is what? Velocity of the wind relative to the car. So, whenever the term relative is given in the question, so automatically it comes in the opposite direction, because now car is moving towards east, that means towards x axis. Since the speed of the car is x, so velocity of the car becomes xi, but wind speed relative to the car that I am finding, that is the resultant. So, resultant of what? Two vectors, one is minus xi and one is minus 3j, that becomes this. But what is given? Speed of the, so here my important point is relative means negative, relative means negative. What is given important point is speed of this wind relative to the car is given as 5. So, this speed means magnitude. Magnitude of what? Magnitude of minus xi minus 3j is equal to 5, that is given for me. That means what? Root of x square plus 9 is equal to 5 is given for me. So, after simplification of this, you will get x as what? 4 meters per second. You will get x as what? 4 meters per second. This they are asking. So, my friends, here you please try to understand the important points: speed, velocity, velocity of the wind relative to the car, and what is speed of the wind relative to the car. Speed of the wind relative to the car is a scalar. Velocity is velocity of the wind relative to the car is, that means resultant. Resultant of what? One is car velocity as well as the wind velocity. Resultant of these two gives us what? Velocity of the wind relative to the car. Since it is given relative to the car, it comes in negative direction. Therefore, it is the resultant of minus xi and minus 3j. So, the resultant means addition of these two, that means minus xi minus 3j, that indicates what? Velocity of the wind relative to the car, but speed is given as what? 5, that means magnitude of that vector is given as 5. You solve this, you will get x. So, here my friends, you thoroughly practice these problems, otherwise you will get trouble in solving this kind of questions in examinations. My suggestion would be, this is one of the most important questions. You will find this kind of questions especially in your physics lessons. You will master all those problems. So, problems from vector application problems from physics are very, very helpful, and nowadays they are asking these kind of questions in competitive examination, especially in mains. Please do practice. Now, coming to the next. Listen, let AB bar is a vector in a 2-dimensional plane. See, no confusion at all. It is in 2 dimension, that means x axis and y axis, xy plane. Not necessary to take the 3rd dimension, not necessary. So, the problem is very simple for you. With magnitude 4 units and making an angle 60 degrees with x axis and lying in the first quadrant, everything is clear. This is the situation. This is the situation. Okay? See, AB, this is AB, magnitude given as what? 4, and angle is what? 60 degrees. Just I have explained in previous video and in previous slide, if it is 4 and if it is 60 degrees, so this is what? 4 cos 60 comma 4 sin 60, the coordinates of B like this. That means this is 4 cos 60 is I think 1 by 2. So, it becomes 2 comma, and this is 4 into root 3 by 2, that is root 3 by 2 root 3. So, the coordinates of the point becomes like this. So, AB bar is what? 2y plus 2 root 3j. See, the same thing I am solving. Hence, represent AB bar in terms of the unit vectors ij. See, if I know B, automatically I can do the things like this. So, AB bar is, this is 2 and this is 2 root 3, therefore, my AB bar is 2I plus 2 root 3j. Very simple question. Actually, this is the problem in other language also. Instead of vector in xy plane or something like that, we have solved the same. Suppose if a line which is making an angle 60 degrees with x axis, then the coordinates of the point B, if they asked the question in coordinate geometry, this is the same methodology we can solve. But the same problem we are solving in what? In vector algebra. But here what they are asking, if you know the point, suppose this is xy plane and if this is point x comma y and this is OP bar, and if it is making an angle theta and if it is r distance, then actually OP bar is nothing but xi plus yj as a vector form, or in this form r cos theta I plus r sin theta j. This also the another way to represent the same vector if you have this kind of information in your hand. Okay? Now, coming to the next problem. A girl walks 4 kilometers westwards, then she walks 3 kilometers in a direction 30 degrees east of north. This is another important word. And stops. Determine the girl's displacement. What they want? Displacement, not distance. That means in vector form you have to write from the initial point of the departure. So, this is a situation, my friends. So, without loss of generality, this is my origin and this is east and this is north and this is south. Okay, no problem. And along x east, this is my unit vector, and along north, this is my unit vector. What happens? A girl walks 4 kilometers westwards. So, she is walking like this. Okay, and westwards, then she walks 3 kilometers in a direction of 30 degrees east of north. See, this is a situation. See, so a girl walking, this is 4 kilometers, 4 kilometers she walked in this direction, and after that east of north 30 degrees she moved like this, and stops. She stopped here. Then I need to find its displacement. So, I need to find this OA bar and I need to find this say suppose AB bar. Then OA bar plus AB bar becomes what? My displacement of that girl from point of departure. So, here this is simple question. What is OA bar? Since this is I and this is minus I in this opposite direction. So, OA bar is what? Minus 4I. That is simple. And since it is 30 degrees, so this becomes what? 60 degrees. Okay. And now I need to find what is B. And moreover, this AB, she walks 3 kilometers in a direction of, so this is 3 is given. So, I know this angle, I know this direction, I know this point. Then I can find this is what? 3 cos 60, comma 3 sin 60. That means what? 3 root 3 by 2, 3 by 2, sorry, 3 by 2, comma 3 root 3 by 2. So, as a vector 3 by 2 I plus 3 root 3 by 2 j, I get it. So, this is 4I. So, what is displacement? OA bar plus AB bar. So, that means 4I plus 3 by 2 I plus 3 root 3 by 2 j. See, the same thing here I am solving. So, OA bar is equal to minus 4I. The girl walks 3 kilometers in a direction of 30 degrees east of north. So, this is the 30 degrees east of north. This is the thing given. This is the thing given. See, and AB is equal to 3 kilometers. Draw this one, and this is about angle. Okay. So, this is 60 degrees. So, finally, I want OA bar plus AB bar. So, AB bar I got it, AB bar I got it. So, AB bar is equal to, because this is 60 degrees. So, this point is what? 3 by 2 comma 3 root 3 by 2. So, 3 by 2 I plus 3 root 3 by 2 j, and OB bar I got it. So, finally, I want displacement. So, from here to here, total displacement from depth minus 5 by 2i plus 3 root 3j, simple, clear. Now, hope you like this video, you please share and subscribe my channel, and we will meet with the next lesson soon. And my friends, please do not forget to check the description, there I am providing very important links for coming lessons also. Thank you once again, and we will meet with the dot product lesson soon. Thank you.